If a potential in volts in a region is expressed as V at x, y, z is equal to 6xy minus y plus 2yz, the electric field in N bar C at point 1.1, 0 is we need to find here. Okay. Given the potential function, that is V is equal to 6xy minus y plus 2yz, we can partially differentiate this one with respect to the x, y, z separately. This yields, that is electric potential, electric field, that is Ex at vector is equal to, that is a partial differentiation, that is a dou V by dou x. If I'm going to get the differentiate this one with respect to x, we get the value that is minus 6y I, and Ey vector is equal to, again dou V with respect to dou y, we get the value that is a minus 6x plus 1 minus 2z times j. Then this is I cap and this is j cap, and Ez vector is equal to dou V by dou z, which is equal to, we get the answer, minus 2y k cap. Thus, the electric field, that is a E vector, we get the value, it is E vector is equal to minus 6y I cap plus of minus 6x plus 1 minus 2z j cap minus 2y k cap. Given the potential, given the point that is 1 comma 1 point, this is a comma, that is a 1.1 comma 1 comma 0, then we get the answer, electric field E vector is equal to, that is minus 6i cap minus 5j cap minus 2k. By substituting the value of 1 comma 1 comma 0, we get this is the answer. So the right answer for this question is, we get minus, that is here it is minus is there, I'm going to take the minus as a common factor, then this becomes 6i plus 5j plus 2k. Then the right answer for this question is option C is the right answer.